Our concept is Atwood machine. So this Atwood machine, as well, this example we are going to be discussed for prove the Newton's laws of motion. Atwood used the system to prepare Newton's laws of motion. Atwood machine consists of two masses. Atwood machine consists of two masses. It is a pulley. For this pulley, there are two masses are suspending. This is I am calling as M2, and another mass. This is M1. These two masses are suspending there. These two masses are suspending with a inextensible string. So what is the question given for us here? The string runs over a pulley. This is a pulley. Okay, find the acceleration of each load. That means what is the acceleration, and also what is the tension we need to calculate. What is the acceleration of the each load, and also what is the tension of the load. That one we have to be calculated. Regarding that one, just we have to draw the free body diagram. Free body diagram shows that how many forces are acting on that. Regarding that one, first we have to take the first load. That means first load, the mass of the first load we are saying has here m1. That's way. Okay, this is a free body diagram. So on this load, there are two forces are acting. One is tensile force. The tensile force is acting towards the upward direction, and also another one is gravitational force. The gravitational force always acts towards the center of the earth. That is m1z, and it is more weight. That means here condition what given is m1 is greater than m2. M1 is greater than m2. That's way. So it is pulling. It is pulling. That's why the acceleration is also towards the earth. That means acceleration. So from the free body diagram of mass m1, there exist two forces. I already told you. The net force, how much here is the net force according to the Newton's second law. What we know is mass into acceleration. But according to this one, this is equals to the m1g minus t, m1g minus t, which equals to m1a, which is equals to the net force acting on that. That's why it is calling as equation 1. So same like that, there is a one more load is also there for us. That is second load. This is also, which is having the mass m2, which is having the mass m2. This is m1. Okay, so here if you observe, the acceleration is acting towards the upward direction. Why? Because it is the less weight when compared to the first body. Here also there are two forces are acting. One is tensile force, another one is gravitational force. That is also we may call as weight. That is weight. So from the free body diagram, the net force how we can write is F net equals to T minus M2G, that equals to M2A. That equals to M2A. This is called as equation number 2. Now we have to add equations 1 and 2. That means first equation is M1G minus T LHS side plus T minus M2G, which is equals to M1A plus M2A. T cancel. That implies M1 minus M2 into G. From these two, I am taking as a G as a common. That equals to, here A is a common factor, M1 plus M2 into A. Therefore, acceleration A equals to M1 minus M2 into G by M1 plus M2. This is the acceleration of the body. This acceleration of the body equation we have to be substituted in either maybe equation 1 or 2. We will get this equation we can call as equation number 3. Substitute equation 3 in equation 1. What is equation 1? So once again I am writing here M1G minus T, which is equals to M1A. This is the first equation. Suppose if we substitute m1g minus t, which equals to m1 into acceleration, what we got here is m1 minus m2 into g divided by m1 plus m2. m1 plus m2. This one we got. So what we want? Tension we want. So we have to be do first multiplication. m1g minus t. Okay, here whatever the term is dividing, if we take that one this side, another side, it will multiply. That equals to m1 into m1 square into z also there, g minus m1 m2 m1 into m2 into g. Now we will do the multiplication. m1z into m1z into m1, that is m1 square g, m plus m1 m2 g minus t m1 minus of plus minus t m2, which is equals to m1 square g minus m1 m2 g, m1 m2 g. Now the left hand side m1 square g, right hand side m1 square g, we have to cancel both. That implies what we know, what we got is, okay, minus t if we taken as a common, m1 plus m2, that equals to minus m1 m2 into g. That implies this term we have to be take this side, and minus term, this term has to be, if we take that one, m1 m2 g minus term plus m1 m2 g, which is equals to this minus term, if we go that side, it will becomes plus t into m1 plus m2. That implies, so from the 2 m1 m2 z, that means 2 m1 m2 g equals to t into m1 plus m2. Therefore what we want is t, that equals to 2 m1 m2 g by m1 plus m2. This is the tension. Okay, thank you.